Hello, good morning. Good morning.
Good morning.
Good. Welcome to another session. Uh, we'll be starting any moment from now. I understand I have not received the assignments yet. Any question or any issue why the assignments have not been submitted?
Please, is it the last one we were supposed to submit last week?
Yes, and the current one too.
Ah,
How far with?
the current one, the in the PDF. Are we? Is it an assignment we are supposed to submit?
Yes.
Oh, okay. I thought it was just a practical we supposed to do on our own.
No. You're supposed to. It's 15. 10 objectives, then five
Yes.
hands-on questions. Yes.
Yes.
Okay.
Oh, okay.
So maybe sorry for the miscommunication. Maybe the clarification didn't go well. So what's going to happen is that you're going to have another assignment added to this one again.
Okay.
By the close of today, we'll have another assignment added again. Hmm.
Okay.
Okay. So on that note, I think we can start today's session. We are six in all. Okay, so Richfield, Grace, and Fosua. Okay. Wow. So the rest have not yet joined. I think they will be joining, so we can start. Okay, so I hope you can see my screen I'm sharing. Okay, so for today's lesson, I'm going to create a new file called lesson3.py. So that's where we are going to do all our lessons in. Then mine is on the PowerShell. I'm going to change it to command prompt. Okay, so I think I'm good to go. Okay, so today we are going to look at tuples as part of the data types that we are supposed to look at. Now, a tuple is an ordered collection of elements enclosed in the parentheses. So these are the characteristics of tuple. They are immutable, meaning their elements cannot be modified once you create them. And there's a reason for that. You see, we looked at list. We're now looking at tuple. We'll look at set and dictionary. They are all data types. The features will help you to know when to use one over the other to achieve what you want. So for instance, if you have figures which are constants, which do not change readily, you can place them in tuples and then work with them. Okay, so let's look at how we are going to create one. So to create a tuple, you just use the parentheses and then you put your values in it. So I have here my tuple containing 1, 2, 3, 4, 5. When I print it out, I'm supposed to get the 1, 2, 3, 4, 5. So let me print this py and see whether I get the same output. Now, you see, I didn't get any output because I have not saved the file. That's normally what we forget to do, to save our document before we run it. Okay, so when I ran it, I got 1, 2, 3, 4, 5. If I want to know the type, I say print, then the type, and then my tuple. Save this and I run it again. I'm shown that it is a class tuple. So I know that I'm dealing with a tuple. So tuple are, you cannot change them once you create them. So there are benefits or reasons why you use a tuple for such instance. Okay. Any questions so far?
Hello.
Yes, please.
It seems you were moving a bit fast. I couldn't follow.
Okay.
Yeah.
Please. Is it the whole show or some aspect?
I started with you, but I got lost at a point.
So exactly where did you get lost?
Um, I think where you were creating a tuple, I can read what you've written there, but I don't know what exactly it's about. So if you can go over, like I think the second, creating a tuple.
Okay. So from the little notes we have here, if you want to create a tuple, we put whatever we assign the variable to this parameter. So if you want to create a tuple, so maybe x will be equal to this. So this is a blank tuple. When I see something like this, I know that I'm creating a variable and I'm creating it as a tuple. So with this, I can now put the values inside it. So I can say 1, 2, 3, 4. So I've created a tuple variable called x, and I've put this information inside. So that's the same thing we did here with my tuple, and I printed it out, and I got the same results: 1, 2, 3, 4, 5. And I said that if you want to know the type of variable it is, you use a type command. So print into brackets, type into brackets, then the variable name. When I printed it out down here, I got that class tuple. Are we now on the same page?
Yes, please.
Good. So let's
Thank you.
continue. You are always welcome. Now, you could also use the tuple function to create a tuple. Instead of assigning doing it this way, you could also use a tuple function. So I can say y is equal to tuple, then into bracket 6, 7, 8. When I print y, I'll still get what? I would have still been created a tuple, and then I'll get the answer. So when I save this and I rerun it, we see here that we get 6, 7, 8. That is the current tuple we created. So either you create a tuple like this, or you use the tuple function and then you put a tuple within another bracket. So mind you, there's a first bracket, and there's a second, there's a next bracket, and then I can put my values inside. So these are the two ways you could create a tuple. Now, accessing elements in a tuple. Now, the tuple, like a list, you can access the data within it. And we start with a zero index. Zero index. So I could let me rename this as y. So I could say print y, and I call the index 0. So who can tell me what the answer or the output will be?
Hello.
Yes.
Yes. I think it should be 1.
Beautiful. Because 1 is at index 0, then 2 is at index 1, 3 is at index 2, 4 is at index 3, and the 5 is at index 4. Good. So that's very good. So it will print 1 out. So let me run the program and get my 1 here. So just as we saw, we could also use negative indexing to get the last output out. Now we can also even concatenate two tuples together. So for instance, if I have y as 1, 2, 3, 4, 5, I have x as 6, 7, 8, 9, and 10, 10. I could concatenate the two and say y plus x. And then you see that it has printed all as one big tuple. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you see that the things we've learned previously, we can apply them to tuple. You can slice a tuple. You can get any element of a tuple using the index. You can also concatenate two tuples together to form another tuple. Now, we can also even repeat a tuple. So let's look at that. Let me create another variable called g, and g is going to be y times 3. I'm going to print g. I'll explain this. Okay, so by multiplying the tuple by 3, I'm repeating the information in the tuple 3 times. So x was 6, 7, 8, 9, 10. So I have 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. So I'm multiplying the tuple. I'm repeating the information inside by the number of times I'm multiplying the information in the tuple. So this tuple, I multiply it by 3. What it means that I want to repeat the information in the tuple 3 times. Now, we also have other methods we can call on the tuple. Now, we can count, you can use the count on a tuple. Count on a tuple means that we want to get the number of occurrence of a variable. So just as I created the g tuple by multiplying the x tuple by 3, I've repeated whatever is in the x tuple 3 times. So when I printed the g out, the output was what I got there. Now I can use the count output. If I want to see the number of 6 I have, I can say print then g dot count. Then I put in 6. When I run it, I get 3 down here. That means that 6 is in that tuple 3 times. So the count method helps us to get the count, the number of occurrence of a particular information we give it. So if we give it another variable, maybe 7, so that means to check how many 7s are in that tuple and then to give you the count. So that is the count command. We can also use the index command to get the first occurrence of a variable. So for instance, if I say print gen.index and I put in the value 9 and I save this, when I run this, it tells me that it is the index or where we see 9. The first occurrence of 9 is at index 3. So let's confirm. So we have the x here, which has been repeated into the g variable 3 times. So if you count here, you see 0, 1, 2, 3. So the 9 is at the third index. So index will let us or help us to know which position the variable is in the tuple. Count will let us know how many times that variable is within the tuple. So those are the 2 methods we've seen so far. Now you can also loop through a tuple. We've not done loops here, but I can also loop through a tuple. So you can say for row in G, print row. When we run this, you see it has printed the information inside the tuple for us. So 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10. So you can loop through a tuple. So a tuple is what we call iterable. We can loop through. So a list, we can also loop through a list. We will see how we can use all of these concepts. We are not understanding the concepts. Now, there's something we call unpacking. And let's look at that. Let me clear everything so far. Now, I have a tuple like this. 1, 2, 3. I can unpack the tuple by saying A, comma B, comma C is equal to X. And print A. Okay, so I got an error. Indentation error. Okay. In Python, indentation is very, very important. If you do not align your things well, you get an error. So there was a space like this, and Python doesn't like it that way. So I brought it back. So that's why I got that indentation error. Now, when I ran this command, I printed A. A gave me 1. Why is that so? I have a tuple containing information 1, 2, 3. Now, when I say A, comma B, comma C is equal to this, what we are doing is what you call unpacking a variable. So what you are telling Python is that the variable X contains 3 items. So put the items, the first one in A, second one in B, and third one in C. Now, if you make a mistake and then you provide more than the amount of variables you have, when you run it, you get an error telling you that not enough value to unpack. So we were expecting 4. By what we said, we are expecting 4 things, A, B, C, D, but we got 3, telling you that there are only 3 things in there in it. So if we want to unpack a variable, you need to know the quantity of items in it. So we can use the length command, len, to know the quantity of items in it. So the len command gave me 3. So we know that there are 3 items in that tuple. So therefore, if I'm unpacking it to to variables, it should be 3 variables instead of 4. So by this, if I run this command now, it will work. And then I've unpacked 1 into A, 2 will go into B, and then 3 will go into C. So that is how we unpack data. Now, when do we need to use a tuple? Now, tuples are useful when you want to store a collection of values that should not be modified frequently. So normally constants or some items which you do not normally change their value, then it's advisable to put. Now, because a tuple you do not change the information in a tuple frequently, data in a tuple is faster. It's faster to read data in a tuple than in other data types. So if you are working with volumes of data and you are not going to change the data frequently, it's advisable to put it in a tuple and then work from it from that end. So that is the reason why the tuple is important. Hello, Richard, how are you doing? Was he in class last week? I don't. So Richard, can you identify yourself? Okay, so as I said, when to use a tuple. A tuple is used when the data you are going to put inside will not be changed frequently. So normally constants or fixed information is normally put inside the tuple. And because tuple data do not change frequently, accessing data from a tuple is faster than accessing data from other data types. So therefore, if you are retrieving data from a tuple, you get the information faster than the other data types. So if you are working with data that do not change frequently and you want to access it and it's high volumes, it's advisable to put them into tuples and then work from there. So as we said earlier, tuples are immutable ordered collection, which means that they are not easily changed and they are ordered. The order in which you put in the tuple is the order in which you can retrieve the tuple out. You can concatenate a tuple, you can repeat a tuple. So those are all that we have to see about tuples. Any question? No question. We move to the other data type. The other data type we're going to look at is what we call set. Now, mind you, we said that a tuple is like this. We create a tuple with parentheses. We create a set with curly braces. We create a set with curly braces. We create a list with brackets like this. So mind you, so I don't get confused. This is a list. This is a set, and this is a tuple. Don't get confused. Okay, so if I want to create a set, I can use the set command. So I can say x is equal to set, and then I put in the information inside my set. So by this, I have created my set. Forgot to bring the equal to sign. I'm creating a set. Okay, so if I clear my screen because of a lot of outputs and then I run the program again, I get 1, 2, 3, 4. If I want to confirm that it is a set, I can say print, then the type into bracket of that variable, save it, run it again. It tells me it's a set. So I've been able to create a set. Good. Another way of creating a set is that I can say C is equal to set, put it into bracket and put it into square brackets like this. When I print this out and I see the type of C, it should give me that is a what set. Okay, set object is not callable. Okay, just a second. Now, there are some features I want you to get with sets whilst I resolve that issue. Now, sets are on and are unordered. We said lists and then tuples are ordered. The way you put the information inside is the way you get it out. But set is unordered. The way you put the information inside is not the same way the information will come from the output or out. Now, sets do not allow duplicates. You cannot put duplicate information in a set. So a very good way of using a set is that maybe you have a data. You'll be giving data, maybe 10,000 records. It contains duplicates. So I can put it into a set. Once I put it in a set, when it sees duplicate, it will remove the duplicate out and only give me unique information. So when I have duplicate data I'm working on it, I can put it into a set and then get it out. Now, sets is very difficult to change information you put into a set. So you should be careful when you're putting information into a set once and for all. It's very difficult. And sets can take other things, just like tuple. So it can take variables, it can take tuple, it can take a boolean, it can take integer or any other. Okay. So with this one, yes. Okay. So you can use the set constructor to create a set like this. So a set is created by putting it into the curly brace or bracket like this as a set, and then you call it like this. So that's how you can create a set. You can also just put the information inside like this. So the first one we saw was the constructor set, and then you give it this information and then assign it to this variable. Another way is just by calling it this. We're creating a set like this. So I say print type set one. Okay, so I said that I get that it's a class set. So either you create a curly bracket and assign everything to it, or you call the set operator like this, constructor like this, and then assign it information like this, and then assign it to your variable. It also creates it as a set for you. So those are the two methods of creating the set. So the characteristics of sets. Sets do not allow duplicates. And then with set, you can do, or if you remember your mass, you remember we saw when we were doing mass and we're doing sets, we saw we had Venn diagram. You can do union, intersection, and all this. So you can do that with sets also. So let's try that. So let me create a set like this. Okay. So union means you are joining two things together. So I have this set. I have this set. So I'm saying you, this second one, that's 5, 6, 7, 8. I'm joining it to X, which is 1, 2, 3, 4, 5. It has been able to print it nicely down here for you. Let's see whether you can use the addition instead of using the union. So let's say print X plus Y. Let me uncomment this one. Let's see whether it will print it for us nicely. Oh, sorry, it's U instead of Y. Good. So you see that unsupported operator, you cannot use the plus. You can use the arithmetic operators with sets. So if you want to join two sets, use the union command to join two sets. And if you want to get the intersection of two sets, use intersection. So let's see this particular one. So I'll say U intersection X. Let me run this and let's see. So I get an empty set. When the two of them intersect, there's nothing in the middle. So I get an empty set. So when you come to sets, just picture your Venn diagram that you were taught in GSS, and then you will know. But the most important feature of set is that set do not allow duplicates. Therefore, if you have a large data and you are asked you to remove duplicates, you can put them into sets. The system will automatically remove all the duplicates for you. We also can look at the use difference. Difference can help us to know the difference between two sets. Now, we said sets are unchangeable, but you could change a set. Once a set is created, we say it's not changeable, but you can change it by using some particular methods to be able to change a set. And the methods we use to change a set is using the add and then remove. Okay, so let me use the X. So I can say X dot add, and then I put in 6. Then let me print X. So you see that was containing 1, 2, 3, 4, but I've added 6 to it. So it is now what? 1, 2, 3, 4, and 6. Now let me add 5 and let me add 6 again. And let's print it out and let's see what will happen. So you see that I added the first 6, I added 5, and I added another 6. But it only gave me 1, 2, 3, 4, 5, 6. So what it means that this second 6 was ignored by the set because 6 was already added. Now, if I want to remove X dot remove, let me remove 5 and let me print it again. So by removing 5, you see that the set is now 1, 2, 3, 4, and 6. I've been able to remove 5. So that's how we are able to use this function add and remove to be able to modify sets.
Hello, sir.
Yes, please.
Please, you said sets are unordered. I don't know if I understood it. You said they are
Yes.
not. Okay, so I was expecting that when you did the X dot add and you had the 6, and you did the X dot add, X dot add 6, you had the 6, and then X dot add 5. I was expecting that when you printed it, it would make it 6 and 5, but it has ordered it.
Yes. So now, unordered means that the list in the set do not have a defined order. The items can appear as arranged in the correct order, but they are not having indexed. They are not being indexed. So even though you are seeing 1, 2, 3, 4, 5, it's not being indexed. That is where the unordered is coming from. Not that it will not arrange it in the way you put it in. So set, it will arrange it for you, like maybe alphabetical order or something like that. But the index method or the indexing of it, you cannot use index on it. You can loop through a set, but you cannot call it using an index. That's where the unordered is coming from. So not in the literal sense that it will not arrange it for you. But if I want to access the data in the sets, I might not be able to use the index way to access information from the set because of the way it treats the information in the set. It doesn't order it, so it doesn't index it. Please, do you get what I'm trying to say?
Maybe I'll wait for an example.
Okay.
Thank you.
Mita, let me try and get an example for you. Okay, so let me try and give you more explanation on that. So the reason why we say a set is an ordered collection of unique elements is that the set do not have a specific order or sequencing that it uses. The information, when you put the information in a set, the information can be arranged maybe 1, 2, 3. It can rearrange the information for you, but it is not indexing the information. So that I cannot say, give me the zero of that set, give me the index 1, index 2, index 3, index 4. In that terms, that's why we are saying it's unordered. Because if it was unordered, then I can tell you that give me the index 0 of that set, give me the index 1, index 2, index 3, and then to give me the information in the right order. So even though it has rearranged the information inside the set, it is not being indexed. That is why we are saying it is unordered. If you are ordering, then that means you can get the index. I can give me the 8th one, give me the 9th one, give me the 10th one. But because it is not being indexed, that's why we are saying it's unordered, but it can be arranged in alphabetical order for you. It is because underneath it, it is using hash tables. Hash table is a way of putting data in memory that you can quickly access it. So when you go to other programming languages like with Java, they will tell you that I'm hashing my data. It's a way of putting the data into memory in such a way that when I'm retrieving the data back, I can retrieve it out. So the way it hashes the data, it cannot be ordered. But with lists and other things, it gives you an index so that I can tell you that I want the 10th number or the 10th information I put inside. I want the 7th information I put inside. So that's why we say it's unordered. Not that it will not arrange it for you. So let's look at some examples and then let's see. Okay, so we saw that we can add and then you can do what again with the sets. We could add and we could remove. Now there's another command called discard. Now what the discard does is that it will remove an element if that element exists in the set. Okay, so the difference between the discard and remove is that remove, you are sure the element is inside, but discard means that you're not sure. So if the element is not inside, let's see, for instance, let's say we put in 8 and you see discard, we will still not get any error, but then this command was not executed because 8 is not inside. Let's look at the remove and let me use another, and let's see something. You see the remove gave you an error, that's the key error. Now it's not inside. So the difference between the remove and the discard is that discard will not give you an error if the element or the information is not inside the set, but remove will give you an error to tell you that that information is not in the set. So if you're not sure of the information in the set, you can use discard. If it's not there, nothing will happen. But if you use remove and the information is not there, it will give you an error stating that the information is not there, as you got key error. Now we can also use clear. Clear will remove every information within our set. I can say clear. And then when I run this command again, so because of this error, let's take this one out. The set is now empty. I've cleared the set. Now, the reason why this is very, very important is that, for example, if I'm looping through a set and I'm taking data out, let me give you a practical example so you understand the reason why the clear is very important. I have a set. Anytime I look through the set of data, I will do something. When I finish, I output the information. If I don't clear the information in the set, when I loop through the set again, that information in the set will always be there, and I'm adding another thing else to it to see that the value might increase and I might not get the right output I want. So clear is a very important command which we use normally when we are looping through sets. That when I loop through a set and I finish what I'm doing in a set, clear the information in the set and start the loop again, and then put another information to a set. Now process the information in it. We'll look at an example when we start looking at the loops, how you can combine all of these things together. Now, you can also loop through a set. So I can say for x in my set variable and print the information out. So set are also literable. You can also loop through them. So as I said, set are used to store unique elements. To store something unique, you use a set. if you want to store something unique, you use a set. Anytime you want to store something unique, you use a set. Now, set do not allow duplicates. Now, you can use the union, intersection, and the difference operator on set to see whether something is within a set or something is not in a set. And then we saw that you could add, remove, discard, clear from a set. So those are all that's about a set. Any question? Okay, so that is it with set. Let's move on to the next data type, that is dictionary. Now, dictionary is a data type you might be using a lot in when you are doing data processing. You might use this type a lot. In other programming language, they call it an array, ARRAY. So a dictionary is also an unordered collection of key value pair. And then we separate the key and the value with a colon. And if you want to create a dictionary, we use the dict function to create a dictionary. And you put it also in the curly brackets. So let's go back to here. We saw that we set, we use curly brackets. When we create a dictionary to also use curly bracket, but a dictionary has a key and a value. So the first information you create will be the key. The second part of the information is a value. Then a comma. You can do another key, another value, comma, another key, colon, another value. So this is how we put information in the set. So I can do like this, that I have name and put here Walter, put age, and put gender. So this is a dictionary having key and value, and it's also not ordered. Unordered means that you cannot use indexing to get information readily available from a key, but there's a way you can do that. If you know the key, you can get its index. If you know the value, you can get its index. But straight away using an index on this, you might get an error. So we'll look at some examples and then we see how to go about it. So I could have created the dictionary that way, or I can also use this way to create a dictionary, the dict command, and then provide the key and a value, key, value, and key and value. So all these tools are dictionary. So if I say print X, I save this and I run this, gives me this. When I say print Y, I also get this. So I've been able to create a dictionary, which is also similar to a set, but it has a key and a value. Key and a value. Now, how do I access the information in a dictionary? I can access the information in a dictionary by using the key. So for instance, let me use this first one, the one I did on top, the X one. If I want to get the information in name, I can say print X, and I put name here. Name is a key. I print this on, you see I get Walter. That is the value. So I can call the name, the key, and I'll get the value. So we say it is key and then value. So you can call, if you know the name of the key, you can call the key to give you the word value. Sorry, this one, I want you to make it a integer. So I'll remove the string out of it. So this is how to access information in a dictionary. You can call the key. Now, so because you can call the key, I can also modify information in the dictionary. So I can say X name, and then I'll change the name to Paul. When I run it, sorry, let me uncomment this one. So you see that I now printed Paul. I've accessed the key and I've changed the value to Paul. So name is now Paul instead of Walter, and I've printed it out. I'm getting back Walter. So that's how to access info, how to change the value if you know the key. And you've not seen how to get the value if you also know the key. Now, I can also add another key per information. So for instance, I can say X school, and I can print a dictionary again. You see that it has added school gateway. to my dictionary. School was not in the dictionary. So you saw that I want to create another key value pair in the dictionary. That's why I gave it like that. But if I had changed this to maybe gender, I know that gender is already inside. So I want to change the value to gateway. So those are the little things you need to take care. Other than that, you might change the values in the key pair situation. So I'll say school rather. Okay. Now, dictionary has some methods that we can use on a dictionary. I can use a method to get all the keys from a dictionary. So I can say print x.keys and use a bracket like this. When I say this and I print it out, it will give me all the keys that is within my dictionary. So if, for instance, if I have a dictionary and I don't know the keys, I will say, and I've assigned the dictionary to a variable called x. I can say x.keys, then bracket, open bracket, close. That is a method to give me all the keys. So if I can get all the keys, then I should be able to get all the values. So if I say x.values, that should also give me all the values. So I can say that print. So the first one, you see that it's giving me the keys, the values. So I've gotten all the keys, I've gotten all the values. So those are how you can access all the keys and all the values to get to know all the keys and all the values. Now, there's another way we can also get all the keys and the values from a dictionary by returning a list of tuples of the keys and the variables, the key and the values. So let's see how to go about it. When I say print x dot items, and let me clear this and let me run this command again. Now, this has returned a set, a list within a set, within a tuple, giving you the key and the value. So the key and the value is within a tuple, which is within a set. So as you can see, because I had it like this, he gave me something like this, name, comma. So we know that from previous, this is a what? Tuple. And then it has put it inside a set. You know that set is a bracket. So you see the way you can join two data types to do some things. So this is a join two data types. So we've created a tuple and we've put it inside a set.
Hello, sir.
Yes, please.
Please, is it inside a set or is inside a list?
Oh, sorry. It's inside a list. The bracket is a list. And then the square bracket is a list. And the parentheses is a tuple. So this is a tuple inside a list. Thanks for the correction. So you see how you join these two together to create another. So this is another data type that you have created. It's a tuple inside of a list. And we all were able to do that because we use the items command. Items command. So I can look through this and then I'll get the various tuples and I can access the information in the tuple to do something. We'll look at using all of these things together to do some work. Now, there is a command that we can also use with dictionary to remove information from a dictionary. So if I know the key, I can remove it from a dictionary. So I can say print x.pop. What do I want to pop? I want to pop the name. So this has popped the name out. So the name is what? Walter. So if I reprint my dictionary again, so that it will not be there. So it will pop. What pop does in terms of our dictionary is that it will remove the information from the dictionary, but at the same time, it will print it out for me. So if I was doing maybe a queue system, I want to do a queue system, maybe first in, first out. So I can put in a dictionary and I can be popping the last item from the dictionary or the first item I created from the dictionary. So I pop it out, do something with it, and then that information will no longer be in the dictionary. So as I add people to the dictionary, I can add them to the end of the dictionary. And as I can be popping people out, queue, I pop them from the beginning of the dictionary. So I can use this to create a queue system whereby maybe you go to hospital and then you want to have a queue. You can use this to implement something like a queue so that you can always be popping from the front and adding from the back so that you have a queue type of system, first in, first out. So that's a scenario in which you can use that. So the pop with the key will pop that particular information out. Now, we also have clear, which is a method. Clear will clear all the key pairs in the dictionary. So if I'm done with my dictionary and I don't want anything to be in my dictionary, I just use dot clear with a bracket open, bracket close to clear everything for me in a dictionary. And then you can also loop through a dictionary. You can also loop through a dictionary. And then you can even loop through the key value pair in a dictionary. So let me give you an example of that. Now I can say for key and value in x dot items. No, we know that items will give you the information as a tuple within a list. So within that list, I can get the key and the value within this item and I can print them out. So with this command, when I do it and I print it out, you see, give me name, Walter, age, 2, gender, male. So the reason why this has worked is that items is popping them out as a key and a value. And we saw that we can do unpacking. Unpacking means that you assign variables to the value that you are unpacking, and those variables will be stored inside. So for a for statement, these two are my unpack variables. So I'm saying that give me the items of this dictionary, and it's going to give it out as a list with key and the value in the tuple. So I'm saying that as you give me this information, put it as a key and a value. So with the first loop, the key will be name and the value will be my name, which is Walter. In the second loop, key will be age and the value will be 2. In the third loop, key will be gender and the value will be male. Then the loop ends. So this is how we can loop through a key and a value using items. And you will be seeing this a lot. Now, when do we use dictionaries? We use dictionary if you want to store data as a key and its value. As a key and its value. So for instance, I'm storing a cumulative record of students. So the name of the student can be the key, or the class of the student can be the key. And then the value can be a list of all their results they got from a particular subject. And then I can do that class 1. The first person got A, second person got B, second person got D, something like that. So we can do it that way. So if you want to store data as key and value pair, we use a dictionary. And because of the key and value pair, it's also very fast to access information from a dictionary. So if you also want to access information from a dictionary where you can also have duplicates, then it's advisable to use a dictionary. But if you don't want duplicates, then use a set. Please, any question? Can I continue? Okay, so I take it that silence means consent. Now we are going to look at what decision making. How do we let the computer make a decision? We are going to look at how to make decisions. So we are going to look at the if statement. Now, the if statement is a control flow statement, and it is used in programming and in other programming languages. And what it does is that you are saying that if a condition, then do something. So if the condition is not met, that thing will never be done. So for instance, I tell the computer that, computer, walk 3 paces to the left, then walk 5 paces in front. You will see a fridge. Open the fridge, take the blue cap from the fridge and return the same way. When the computer is following your commands, when it gets to the fridge and opens the fridge and doesn't see the blue cap there, the computer will hang because it does not know what it's supposed to do. You didn't tell it what it's supposed to do. If I don't see blue, so the computer will hang. Then you see that my computer is frozen. So decision making, the if statement can be used in such a way that, okay, if you see blue, do this. If else you don't see anything, return back and tell me you didn't see blue. Then the computer will return back to you and tell that I didn't see the blue cap. So if statement is a control flow statement, which is used for making decisions, evaluating a condition, and then based upon the evaluation, it will do a particular thing. So the syntax is that if condition, do something. So this is how we do the if statement. So the if statement is that if condition, then you read a colon, enter, do something. This is how the if statement works. Let's look at this example and see something. Now I have a variable called num, which contains the integer 5. I can say that if num is greater than 0, it should print the number is positive. This statement is executed only if the condition is true. So if I save this and I run this, it tells me that, oh, let me uncomment this one. The number is positive. The statement is executed only if the condition is true. So if the number is greater than 0, so let's make it negative and let's see something. If I make it negative and I clear this, if I run this, nothing happened because I didn't tell the computer to take care of the scenario whereby the number is less than 0. So it printed nothing. So what it means that this condition was not met. So this thing didn't come. So if I wanted to do that, I could have said else and say print. I can say negative number found. If I save this and I run this. Okay, so let's relook at the question or what you've put on the statement again. I'm saying that if the number is greater than 0, then it should print this. Else, it should print this. Okay. Let me save this. Let me run it. Let me see something. Oh, I was pressing the clear command. So Python lesson 3.py. When I run this command, I get negative number found. Yes. So I've given the computer the ability to make a decision based upon the scenario that if the number is greater than 0, these two things should be printed, else it should print this for me. So this is the way I can make a decision with the computer. So I've said that if that number is greater than 0, it should print this, else it should print this. So that is the if statement. Now, when we are writing the if statement, we should be careful. You see the indentation, there's space between space here, there's space here. If you do not give those space, you get an error. But luckily for us, as we are using this code editor, when we put the colon and reverse enter, it automatically created the space, the indentation for us, and we typed it. But if you're using a text file, you should automatically create the indentation yourself. Other than that, you get an error. So that's with the if statement. Now, how do I check? For example, I've been told to check if a number is odd. Now, to know that a number is odd, you can use the modulus command to divide the number. If the remainder is 0, then that means it's an even number, else you get an odd number. So that's how you can check whether a number is an odd number. So let's look at this particular one. So I use the modulus command, which is in Python's percentage sign. When I divide this by this and the remainder is 0, it means it's an even number, else it's an odd number. When I run this program, I get the number is odd. Now, let me show you how I'm going to combine some of the things you've learned so far to write a simple program that can give us all the odd numbers between 1 and 100. Now, I told you in the previous exercise that if I want to get a range of numbers, I use the range command, range. And then any amount of information I put inside is going to start from 1, 0 to that range. So this one will start from 1 to 99. It will not add the 1. So if I want to make it 100 exactly, I have to make it 101. So I can say x is equal to range this. When I print x out, I get range 0 to 101. I get range 0 to 101. So this means that I'm getting a range of numbers from 0 to 101. I can also say I want to start from 1 to 101. When I save this and I run this again, you see that the range is now starting from 1 to 101. Now, I want to get all the odd numbers from 1 to 100. How do I go about it? I've not learned the for statements yet, how to loop, but I know if statements. Now, I'll know that I can use range to be able to what? Get a range of information. Now, I can also create what? A list. I can say this is odd and then create a list like this. I can say even and create a list like this. Then I can loop through my range. So I can say for row in X, if I say print row, let me clear this once and let me show you something. By this statement, what I'm doing is that it's going to print from 1 to 100. So this is that printed from 1 up to 100. So there's no need for me to create a list. There's no need for me to create a list and say 1, 2, 3, 4, and do that to 100. The range command has done that for me. Now, so I'm combining what I've done so far to this to do something. So I'm going to loop through this range I've created. Then I'm going to say that I'm putting the if statement within the for loop. So you're going to loop through the 1 to 100. So if row, I divide it by 2 and it's equal to 0, then I can say that it's an even number. So even dot append row. Else it should be odd dot append row. So what I'm doing is that I've created an empty odd list, an empty even list. If I divide the information through the loop by 2 and I get a remainder of 0, add that number to my even list. So let me say even number. Else add that number to my odd list. It's an odd number. So this will do the loop. After that, I can say that print all even numbers from 1 to 100, comma, and say even. Save this. Let me clear this and run this command. So you see all even numbers from 1 to 100. That's giving me a list of all the even numbers for me. And instead of me printing them one by one, I put them into a list using the append command to add to the list. And then I have also all the odd numbers here. So I could have said that if I want to make this nicer, I can say that print all even numbers from 1 to 100. And then I print my list even. Then I can do the same thing. I can see all odd numbers and print my odd. I want to let there be a space, so I can print an empty here to get a space. I save this and I run this. Let me clear it first. I want it to be a blank sheet. So I've got a list of all the even numbers, the list of all the odd numbers. So for instance, you will be giving an assignment, get me all the even numbers from 1 to 1 million. So all that I do is that from 1 to 1 million, I just make sure that I make this one. How many zeros? 3 zeros makes 1,000. 1 million is how many zeros? How many zeros make a million? 6 zeros.
Six.
So I can do the range. So I have to do it. If I want exactly 1 million, add 1 to it. Because other than that, it will do up to 999,000.
Hello.
Yes.
That's 100,000.
That's 100,000.
Okay. So this is 1 million.
No, it's 6 zeros.
So
The zeros are supposed
1,
to be
2,
6.
3, 4, 5, 6.
Yes.
Okay. So by this, I can get a list of all the even numbers and all the odd numbers between 1 and 1 million. When I save this, let me clear this. Let me run it again. So it has listed all of them for me. So you see how we are using list, we are using range, I'm using the for loop, I'm using if statement, all to combine to be able to execute an assignment. So you see that all the things you are learning, you start combining them all together to be able to produce something. So we see all the odd numbers. When I scroll to the top, I'll see the space, and then we see all the even numbers. So for instance, if I wanted only the even numbers, print all the even numbers for me. Good. So this is how we've been able to combine some of the things we've learned so far, and even something we've not learned yet, the loop statement. We've not done the loop, the for loop, but we're able to combine all of this to be able to generate something. Now, we can also do multiple conditions. We can do multiple conditions with our if statement. So for instance, I'm saying that if my number is greater than 0, and at the same time, if when I divide that number by 2, the remainder is 0, then you should tell me that it's a positive and at the same time an even number, else it is a negative number. So the end statement means that the both conditions should be met. So if condition 1 and condition 2, you can always do and condition 3 and condition 4. You can do as many conditions you want. Do something. So this means that if all the conditions are met before do something will work for us. So in this, you can also put them into brackets to help you to make it easier for you to read all that you are doing. Okay. So if this condition and this condition are correct, the statement will work. Now, you can also use an or. The or works this way. If one of the conditions is met, it will still execute the program for you. The if statement, the end statement will only execute if both conditions are met. The or will only execute if one of the conditions are met. So when you make a decision, and sometimes you need to make only a decision if something is met. One condition is met, but you have two conditions you are testing. Then you can use the or statement. Now, we also have what you call a nested if. We have what we call a nested if. Okay, so this is an example of a nested if. In other programming language, they use else if, but in Python, it is else if. So in Python, it's else if. This is how we use the else if. Now, this statement says that if number is greater than 0, you should print this. The else if means that if this first condition is not met, test another condition. So if the number is less than 0, do this, else this. So this is testing two conditions. This is the first condition, this is the second condition. So if both conditions are not met, that's when it will print the number is 0. So let me give you a number. Let's say the number is indeed 0 and save this. When I clear this and then run this, the number is 0. If I make the number 7, save this and I run this, the number is positive. Okay. So that is one way of doing the nested. Another way of doing the nested is that, for instance, if gender is equal to female, and do another if again, and if within an if age is equal, mind you, so we saw the you can use the is command. I can say is equal to also. So if gender is equal to male and the age is equal to, maybe, let's say if the age is less than maybe 16, then we print that maybe cannot marry. I think Ghana now the legal age for a woman to marry is 16. Or else print can marry. So I can come here that if gender is equal to male, and if age, the same thing, is less than 16, print let me say he can marry. Let me do here she. So he cannot marry, else. So this example of a nested if, whereby we have an if within an if. If I say female and age is 5, Okay, so female age is 5, so that means that she cannot marry. If I make it 25, he can marry. If I make it male, okay, so male now, why did we get this error? It says she can marry. Okay, so let's see. Gender, oh, I didn't save it. Okay, I didn't save when I made the changes. I didn't save. So he can marry. So you see the way we have done a nested if, an if within an if. So you can use this to make a complex decision making that the computer can follow to make a right decision. So for example, if you're doing a payroll, if your salary is within this range, then do this. If you have allowance of this, do this, do this. You can use that to structure a complex if statement that can be used to do a particular task. So the if statement is one of the most powerful decision-making tools that we use a lot in Python and in other programming languages. And we've seen the nested if. Now, there is another thing I wanted to say about the if statement. Now, if you are constructing an if statement, if you don't take care, you might make a mistake with your indentation and even the logic. So, for example, with this one, I could have built the output first. I'll just put, there's a command called pass. We'll look at that later. So I can build the skeleton of my statement. And then within that, I start building the nested if within the statement. Other than that, I might make a mistake indentation or I might make a mistake with the logic. So if I'm doing a nested if statement, I build the skeleton first before I build the further if statements within it. That's what I wanted to say, that if you don't take care, you might make a mistake when you are building the if statement. So you should be careful about it. But after doing it for some number of time, you will get the how to go about it. Any questions so far? Any questions so far?
No question.
Yes, please. Please, your question. I thought I heard somebody saying one question. You said no question. Oh, okay, okay, okay. Okay. One time, welcome. And then I think Justina just joined. Welcome. You've missed a lot, but as we said, you can always go through the video and the lesson note that will be provided. And then if you have any question, you can DM me and then we would look at them. Okay, so if there's no more question, we would look at the last topic and then we can call today's session a success. We are going to look at loops. We're going to look at loops. How do we loop through information in using Python? So a loop is also a control flow statement used in Python for iterating through a sequence. So you can loop through a tuple, you can loop through a list, you can loop through a string, you can even loop through a range. So for instance, if I had name and the name was Walter like this, because it's a string, I can say for row in name, print name. This will loop through my name and print the character by character. Okay, so this has printed it like this for me. Name is equal to this. Okay. So the syntax for a loop is that we loop this way. For item in sequence, then do something or code to execute each item. So for item in sequence. So this item variable is what would be assigned the item the anytime the sequence is looped or run through. So if I have data like name, I'll say for row in name. What it means is that anytime I loop through name, the information that comes out from name will be stored in the variable called row. So I should have called row instead of name. That's why I got that error. Repeating my name 5 times. Sorry. So this that's printed character by character, WALTER. So what is happening is that anytime I'm looping through my name, it will pick it character by character and it will assign W to row, then to print row, and to assign A to row, then to print A, then L. So that's how we go about it, row by line. So that is the for statement, and then how we go about it. So we said you can loop through dictionary, list, string, tuple, set. If I have this, let's look at this example. If I have this, for I in range 5, print I. Now, when we say range 5, it's going to give you 0 to 5, but actually it's going to print 0 to 4 because the last one will not be printed. Going around this, I guess 0, 1, 2, 3, 4. That's a range. And in range, if I want to start from a particular number, I bring that number first. So range 1, 2 means start from 1 to 5. So this one will start from 1 to 4. 1, 2, 3, 4. So that is how we use the for statements to loop through information in Python. Now, there is a statement or there is something in Python that we can use in the for statement. We call it break. Break means that stop the loop and then return. So let me give you an example. If I have x is equal to range 1, 1 million. 1, 2, 3, 4. Have this. I can say for row in x, if row is equal to 9999, print found number, and I say break. Now, what this is going to do is that I'm going to loop through x, which is going to give me a range from 1 to 1 million. Now, each time I loop through x, the value from x will be assigned to row. So whether I loop through x is 1. So 1 will be assigned to row. Loop through again 2. Loop through 3, 4, 5. So anytime it's looping through, row takes the value that is assigned to it. Now I'm saying that if row is equal to 9999, if row is number 9999, then it should print that found number. Then it should break. Break means that I should break through this loop. Don't continue the loop. So we use break to stop the loop after we have achieved what you want to achieve in the loop. So if I print this out, see, it printed for a while, then said found number. I could have also said that found, let's say, comma, row. You see, found number 9999 and then break. If I wanted to know what it was printing, I can say print row. So this will start printing for me. When it gets to that number, it will stop. Good. So it has stopped for me. Found number, this, it has stopped for me. So that's how we use the break command. The break command should stop the loop when you as a programmer thinks what you want to achieve, you've achieved, stop the loop. So that's what the break command does. It breaks through the loop prematurely. Now, so the rest of the loop will not continue. Now, we also have continue. Continue statement can be used within a loop to skip the rest of the code for the current iteration and move to the next item. So let me show you how the continue works. If I have this and then I give this command, when I print this out, so it printed apple, banana. It didn't bring the banana and printed cherry. Why did it do that way? We said that it should loop through fruits and assign the value to fruits. So in the first loop, it check that if fruit is banana, it should continue. So it checked fruit is not banana. So it will print, it printed the fruit out. That's apple. Then in the next one, now fruit is banana. So if fruit is banana, continue. Continue means that it will go back to the loop. It will not print it. It went back again to start the loop. And when it started the loop again, now fruit is now cherry. And cherry is not equal to banana. So it printed the cherry out. So that's why I printed apple and cherry, but it did not print banana because of the continue command. When it sees continue, it will go back to the loop at the beginning of the loop and start. It continues from there. It will not print the what the current position. It will not execute the code there. To go back and start again from the top. So that's the difference between the break and then continue. Now you can also use an else clause for an if statement for a for loop. So I can say that I've done it this way. I say that for fruits in fruit, print the fruit, else it should tell me that all fruits have been printed. When I save this, clear the screen, run this command again. It prints them all out, then it prints all fruits have been printed. So if you want something to still execute after your for loop, you can use the else statement with the for loop and to print that particular information for you. So this means that after printing everything else, it tells you that all the fruits have been printed because of the else statement. So you can use if else. You can also use for with an else statement. So this one means that print, do everything here, and then it will print this one here for you. So that's how we use the else statement. So in conclusion to the for loop, for loop is a very powerful constructor in Python for iterating through sequences or performing repetitive tasks. And you can loop through a list, tuple, string, range. You can combine it with other things to do what you want to do. Now, you can break between a loop, you can continue a loop, and you can also use an else statement with your loop. Now, let's look at the second type of loop that we have. Now, we also have the whilst loop, whilst loop. So, while loop in Python. Now, it's also used as a control flow statement for controlling the execution of a particular block of code or to repeat a particular block of code. Now, it is a little bit different from the way we use the while loop than the use of for loop. They all have their use case scenario. Let's look at how we use the while loop. The syntax is whilst a condition do something. So let's look at a while loop. Now, a while loop has a counter. A while loop should always have a counter. And then whilst it's counting, it's checking whether the condition has been met. If the condition has been met, then the loop stops. So this one, I have a counter called 1. I can name the counter any variable. So whilst the counter is less than or equal to 5, then whatever is within the while loop will be repeating or will take place. But inside your while loop, you should always increase your counter. If you don't increase your counter, you get what you call a perpetual loop. It will loop till Jesus Christ comes. And with this one, it will start taking up memory space. To all your machine memory will be full, and then your machine will crash. So it is important to always provide a counter and increase the counter, and then test the condition. So this means that this thing will run 1, 2, 3, 4. Let me run it and let's see something. Okay, so you see that this thing has run, 5 times. So for the first time, it printed 1, 2, 3, 4, 5. And we say that if it is greater than or equal to 5, then it should print. Now, what if we say it's greater than 5? Let me save this and run it again. Now, you see that this one, it printed up to 4. So what is going to happen is that in the first loop, x counter is 1, so to print 1. Then it will add 1 to 1. You saw the shorthand. This is a shorthand. It will add 1 to 1, so it becomes 2. Then it becomes 2. 2 is less than 5, so to print 2. So go to 3. 3 is less than 5. Then you go to 4. 4 is less than 5 to print it. Then when you come 5 less than 5 is not. So so it will not print again. But if you added the equal to sign, then it will print up to 5 for us. So that's how we use the while loop. Now, as I said, you should be cautious. When you're using a while loop, you should have a counter and you should be increasing your counter. If you don't do that, you have what you call an infinite loop or a perpetual loop. A perpetual loop will be looping forever. And as it's looping, it is taking up your memory space. It will do that till all your memory space is full. And then if your memory space is full, your machine will crash. So you should be careful about that. And if you are in a perpetual loop, you forget, and you're in a perpetual loop, you can use the Control plus C key to break out of the loop. Now, we also have another one. Let me show you an example of the perpetual loop. This is a perpetual loop. We will not run it, but I'll show you. This is a perpetual loop. True print. This is a infinity loop. Let me save this. Let me run this. It will print this forever and ever. So if I press Control C, I break out of the loop. Now, why did this thing print continuously forever? I'm saying whilst true, and I've not given it any condition to know that it's false. So whilst true, it will print this till ever. So to avoid perpetual loop, make sure that you have a counter and then you increase your counter so that the condition will be met and then it will stop the loop. Now, you can also use break statements within your loop. So let's look at doing one with a if statement also. So I have my counter. Now I'm saying whilst true. Whilst true, this is a perpetual loop. Whilst true, I'll print the counter. And then I add 1 to the counter. Then I check if the counter is greater than 5. If the counter is greater than 5, it will break. So this one is a way of mitigating the perpetual loop. When I run this, it prints 1 to 5 and break. So even though this here is a perpetual loop, I'm still using the if statement to check whether the condition will be met. If the condition is met, then I use the break to break out of this while loop. So that's how we go about that. We could also use the continual statement here also. Let me save this and run this. Okay, so let's look at this example. So nothing printed out because we're not printing anything out. But let's look at this statement. Whilst the counter is less than 5, increase the counter. Then check if the counter is equal to 3. If the counter is not equal to 3, to continue to do that at 3 times. So let's put a print here. Add this. Now, this part of the code printed 1 to 5 because even though we are checking for this condition, we say it should still continue. So even though the condition was met, we should still continue with our loop. So that's why it was continue and it printed the 3, 4, and 5. Other than that, it should have printed up to the 3, depending upon the condition put here. So I can say that if I said if it's greater than 3, it should break. And this one will do up to, if counter is greater than 3, it should break. So this one printed up to 4 because it's greater than 3. So if I use the less than and I run this program to get 1. So what happened? In the first instances, 0 plus 1 is 1, and 1 is less than 3. So that's why it break. It didn't continue again. Now you can even use an else clause within our while loop. So let's look at the example. So we see how we are combining a lot of things we learn together to do something. So I can say that whilst my counter is less than or equal to 5, print counter and then increase the counter. So after doing that, else loop completed. So this will print only when we finish with our else statement and then to print that the loop has printed. You saw the way we did it with the for statement. We could also use an else with a while loop statement. Okay, so on that note, that brings us to the end of this session. Any question? Now, somebody made a comment that the quiz questions I gave was too much. I gave you 10 objectives and then 5 hands-on. My intention is not to punish you people, but my intention is to make sure that you are really grasping the concepts. So that's why I gave you a lot of those assignments. Now, another misconception was that it was a quiz. So I'm making next time I change the heading to assignments. You're supposed to answer it and then submit it. So currently it means that all of you owe me 2 sets of assignments. Lesson 2 assignments. Only 2 people have submitted lesson 2 assignments. The rest of you owe me lesson 2 assignment. And I'm going to give you lesson 3 assignment. Now, this lesson 3 assignment is going to be a mixture of what we've learned so far. And please, when you get the question, don't make up your mind, hey, this question is too difficult. Try and understand the question, break it down. And then if there's any reason why you still not be able to resolve the question, just DM me and then I'll assist you or help you with the solution to the question. So please, when you get the question, don't shout that, hey, the questions are too much. It's all with the idea of trying to make sure you really understand and practice what you are learning so that you can apply it to what you are doing. So on that note, please, if there's any question, please, the floor is open.
Hello.
Yes.
Yeah, Justina here.
Yes, Justin, how are you doing?
I'm good. I got lost at a point, but that's not a problem. Um, I was asking the mode of submission. In the mail, you indicated that we should send it via to a Google Drive, and then I think we should copy you. But um, I don't know. I've not tried, but I don't know how to go about it, or I should
Okay,
contact George later.
Yeah, but let me give you some small steps. Say you have a
Adding.
Gmail account. I want to give
Yeah.
you some small steps, but you can
Okay.
contact
You.
George for more. You have a
Yes, I
Gmail
have a
account.
Gmail account.
Yeah, so you can go to your Google Docs for your Gmail account, and then you create a folder, maybe lesson 2 or lesson 3, and then you put your documents there. But you have to make the permission all permission so that I can have access to it when you send me the link for me to also view the information. But George will give you a comprehensive steps on how to go about it.
All right.
Any questions so far?
Hello.
Yes. Is it
Hmm,
for you?
Ufusua.
Sorry.
Is the in-person training, will it come
Yes.
on before the final in-person day training?
Yes. We are looking at next week Sunday.
Okay.
Yes. So we'll communicate that to you.
Okay. All right. Sure.
Okay.
Thank you.
And then one of the reasons why we are looking for you to do the assignment is that we would be pairing you in twos for you to we'll give you an assignment that will be your final assignment that will encompass all that you have learned to write something, a program, and then we want to put you in twos, in groups of twos. So we want the assignment to know your level in terms of how you answer it so that we can pair you together for you to be able to do the assignments. And as we said, it's not to scare you. If you have any issue, just contact me. But you see that when you get your hands dirty with the assignment, you would really appreciate what you've learned so far and how you can apply it to day in, day out scenarios. So that's one of the reasons why we want you all to be able to do the assignments. Yeah. So please, you can DM me anytime. Once I'm awake, I would respond to your question or your issue for you.
Hello.
Also, you could put the question on the, if you like, I can put the question on the page so that if somebody else has a similar question, has a similar issue, he can know how we went about to resolve it. Okay. Please, the floor is yours. Wanted to speak.
I wanted to verify something.
Yes.
I wanted to know if the schedule had changed because previously it was supposed to be 8 weeks, but I realized it's been changed to 4 weeks, or every time I've been pushed into the 4 weeks.
Okay. So the new schedule we proposed to you was for 4 weeks.
Okay.
Now, it is not cast in stone. We might increase it to the 8 weeks depending upon the assignment submitted, the answers you give, and also the various tests, the other tests you are going to do. We are going to look at your the answers you are providing to make sure that it's on point. If it's not on point and we need to go back through some information again, we might do that. So that's why we are adding because of the 4 weeks, that's why we're adding the Sunday. But if there's a need for us to increase the days to make sure you get everything, we will still do it.
Okay.
So it is not cast in stone. But for now, it's the 4 weeks with at least 2 Sundays session in addition, which will probably start next week.
Okay. Thank you.
You are welcome. Okay. Do you have any question? Any question? Okay. So if there's no question, I'll hand over to George. If he has anything to share, then we'll call it a day.
Good afternoon once again, and thank you all for joining today's session as well. Please, the video that we have been uploading, I noticed that most of you have not been watching it. I don't know if there's a problem with that, or it's too long to go through them again. Is there any issue with that? Because we want you to be able to learn it on your own, like to practice it as well.
Please, I'm okay with the videos.
Oh, okay. And one time, I think you are the one that you said you are you attend church on Saturdays, right? So please, when you start the in-person on Sunday, make sure to come so that you get some practical understanding of what you are doing. And Richard, please, are you the one who keep on joining with different usernames? Richard, please, are you here? Are you on the call? Okay, one time noted. Okay, so you're in church right now. Okay, so if there's no any other question, please, we'll be sending you the video, the recording, and your assignment to please. We entreat everyone to submit their assignment because since most of you have not been cooperating when it comes to the assignments, you have not been submitting it. And with the Google Drive too, please, once you have a Gmail account, you have Google Docs and Sheet on your on your account, so you can easily create a Google Doc account and submit your use it to do all your assignments. It's just like the Google Doc is just like the Word document that we've been using. So it's just as simple as that. But if you have any issues on how to access that, kindly let me know. I'll give you an index tutorial or something about how you can sign up on that one to be able to submit your assignments. Okay, sure. So then we call it a day. So see you on next week. Have a great week. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.